All right, let's dive in. We all look at electric cars and see this clean, green future of driving, right? But what if I told you that hidden inside most of them is a component with a pretty significant and kind of dirty secret? Today, we are going under the hood to uncover this massive global engineering race to reinvent the very heart of the electric car. Now, when you think about what makes an EV go, your mind probably jumps straight to the batteries. And yeah, they're super important, but the real magic, the thing that actually turns electricity into motion, happens in the electric motor. For decades, the best, most powerful motors have relied on let's call it a controversial set of ingredients. So what exactly is this hidden problem? Well, it all boils down to something called the rare earth problem. And believe me, it's a challenge that has automakers and some of the world's best engineers scrambling for a solution. So what are these key ingredients? They're called rare earth elements, or REEs for short. Think of them as a group of 17 metals that have a kind of superpower. When you mix them with iron and boron, they create the most powerful permanent magnets known to humanity. No joke. And these supermagnets are what make EV motors so incredibly efficient, powerful, and compact. Basically, everything you want in an electric car. But, and this is a huge but, there's a massive catch. Over 90% of the world's processing for these rare earth elements is concentrated in China. This creates an absolutely enormous supply chain risk, leaving pretty much the entire global auto industry vulnerable to price swings and, geopolitical tension. And, the problem goes way deeper than just geopolitics. The environmental cost is severe. I'm talking habitat destruction, water pollution, and even radioactive waste from the mining process. Add in that supply chain risk, and you get serious economic instability, with costs that can just skyrocket overnight. The bottom line here is that the so-called green motor has a very, very ungreen secret. So this brings us to the next chapter in our story, this global quest to find a better way, a real alternative. The mission couldn't be clearer. Reinvent the heart of the electric car. Engineers everywhere are literally going back to the drawing board, trying to design a motor that's just as powerful and efficient as the rare earth versions, but without all the baggage. It's a super high-stakes race with billions of dollars on the line. So, who are the main players in this race? Let's meet the different technologies that are all competing to become the new industry standard. Okay, first up, we have the original rivalry. On one side, you've got the old guard, the permanent magnet motor, the undisputed champion of efficiency and power. And on the other side, you've got the comeback kid, the induction motor. This thing needs no magnets at all. It's tough as nails, and maybe you've heard of it. It was famously used in the early Tesla models. And then you have the reluctance rivals. Both of these use a really clever physics principle called magnetic reluctance. The easiest way to think about it is that they guide a magnetic field along the path of least resistance. The switched reluctance motor, or SRM, is super simple and incredibly durable. The synchronous reluctance motor, the SynRM, is a bit more sophisticated. It offers higher efficiency, but it needs some really smart software to make it sing. So if these alternatives exist, you're probably asking, why hasn't the entire industry just switched over already? Well, like with any big engineering problem, it all comes down to trade-offs and some pretty serious challenges. And here it is, the central dilemma laid out right in front of us. Look at this. The RE-free motors are way cheaper, we're talking 20 to 40% less, and they're much more sustainable. That's a huge win. But there's a performance penalty. They have lower torque density, which means you get less power for the same size motor, and their peak efficiency is just a few percentage points lower, which can, of course, affect an EV's total range. And listen, this isn't just some theory on a whiteboard. Major automakers are already placing their bets on these technologies. Tesla, as we said, was a pioneer with induction motors. BMW has developed its own really high-performance magnet-free motor for cars like the i4, and Renault-Nissan, they have their own unique approach too. This is all happening right now in cars you can go out and buy. So what are the specific hurdles engineers are trying to jump over? First is power density. Basically, how do you get the same punch from a motor that's naturally bigger and heavier? Second is something called torque ripple, which is a fancy term for a vibration that can make the car feel a bit rough or noisy. Third is heat. These designs just tend to run hotter, so they need better cooling. And finally, they need incredibly sophisticated software to squeeze out every last drop of performance. But here's the good news. For every single one of those challenges, engineers are developing a solution. So let's take a look at how they're actually engineering a truly sustainable electric future. The path forward really breaks down into 3 key areas. First, discovering brand new materials. Second, completely rethinking the physical design, the architecture of the motor. And third, using the power of AI and advanced software to control these motors with incredible precision. The materials science part of this is absolutely fascinating. You've got new magnet materials like iron nitride that are getting a lot of attention from big players like GM and Stellantis. Others are looking at things like manganese bismuth to slash costs. And some teams are just taking cheap, common ferrite magnets, the kind on your refrigerator, and making them way more powerful through clever new design. I love this quote from researchers at Oak Ridge National Laboratory because it just perfectly captures the engineering mindset. To get rid of those rare earths, they had to solve a really tricky heat problem. And their solution, what they call an acceptable compromise, just shows you that this is all a constant balancing act between physics, costs, and performance. And you know, the secret weapon that's letting them solve all these problems so quickly is the digital advantage. Engineers aren't just building a motor, testing it, breaking it, and starting over anymore. They're using powerful computer simulations and AI to design and test thousands of variations digitally. This is massively, massively speeding up the pace of innovation. So we end with this thought. While we're all focused on bigger batteries and faster charging speeds, could it be that the next truly revolutionary breakthrough in electric vehicles is the one component we almost never see? That silent, invisible motor, finally freed from its dirty little secret, that might just be the thing that powers a truly sustainable future.